Hello. In this video, we are going to continue our journey into making a web server in Zig. We are actually getting close to finishing this series. In this video, hopefully we can make path parameters working. And let me see what's wrong. This ray of light in here. Let me pause this, try to fix it. Okay, I think it's fixed now, yeah. So we will try to fix the path parameters today. There was, I think, 3 issues in our GitHub. Can I open it? Yes. So there were 3 issues. Middlewares and path parameters are the features we need. And finally, we need some testing. So let's start with adding. So for path parameters, what I was thinking is the simplest form of routing is using Regex. There are better approaches like radix trees, but I'm gonna use Regex because it's simple. The Regex library I found, which I played around with a bit, and I think it would work for us, is this Zig Regex from Thai. I don't know. I cannot read this, but thanks anyway for the library. I'm gonna use this. So in Zig, the way you add libraries is, for now, is just you add a package basically. So I built a bit about Zig build system. There are basically 2 ways or 2 kinds of libraries or packages in Zig. One is called library and the other one is called package. Most of the time, package, I think all of the time, package is just a Zig source tree. You point it to the main file, which imports everything else, and basically your own code, for example, this here, the src is just a package, and the main is just the entry point. And it's similar for other packages. And what we are going to use is also a package, but there are libraries as well which you can use, and those are most of the times things that expose a header file and an object file. So they can be, for example, from a C or C++ code base as well. But for this matter, we just need a library. We just need a package. And also there is a better way, which I think it's better, to define our packages like this. As a reusable component, because also we need to add them for tests. This is what I've learned, because actually test executable, as you see, is a complete separate thing from the binary that we have exe, that executable of the normal code. So they are pointing to the same file, but actually maybe we change them later, but for now it's okay to just point to the same file. Actually, no, let's just do this for now. So there's this test.zig, which is our test entry point. So basically testing is just another way of so the test by the executable is just another executable. So our package name is going to be regex. Our path is going to be, and path itself is another file source. And if we take a look at the file source, we cannot. It has this structure. And I'm gonna say depths. I'm gonna put this in depths as a git submodule into regex source regex. Okay. And this will add regex. Cool. So let's do git submodule add this. Okay, it says if you want to reuse git submodule. Oh, I've already added this once. I was playing it this. It says It says it git directory is found. Okay, so now in the depths regex, we have this library. Cool. So let's start. I played with this a bit before, so I don't make this video so long. So let's create the test file we need. Like most of the zip code, let me this. I think it's okay. Const. We need the std. So test. I want to do just a small test of regex. And okay, so the regex library, if you take a look, needs this. So import the main file and the struct regex. Okay, so import main file is in regex. So basically this regex we added as a package in our build.zig is pointing to the main file of this library. Make this regex. Now we can say constant pattern is regex dot compile. Like Go and other programming languages, we can use regex.compile, and I think regex.compile is actually doing it in compile time. I don't know. I'm not sure if it is doing it in compile time or runtime. I don't know. So let's compile it. So what regex we need for our router? So basically what we need. So imagine we have something like /name/ some name we want to capture, right? We need to first of all turn this into a valid regex. So something like for now let's just say this, and this is basically what we need. Maybe we need to make this capture a bit better. So sorry for one disruption. Okay, so the regex we need is coming from the user, but let's say we have something like this. So user can either put the slash in or not. This is actually when this is the at the end of the user URI for that is registered in the router. We add this slash and question mark for optional slash. So now we can say pattern.match. If you take a look at the Safari in match, we can check match for if it will match with the user URI, this API. There's also this captures, which will give us captured groups. We maybe just use that. Actually, let's just use that, captures. So this will give us captures. And I think these all are tries. And try, right? For some reason, the LSP server is not working. So capture is both an optional and also error. So we do a try, and then we need to check if it's valid. So try captures with, for example, this input, so it should match. So we should say std try std testing.expect captures dot optional value dot slice at. You see that we need to, so captures are in an array and we need to point at them with a slice at function. Slice at, I want the second one because the first one, it says it returns the entire match, which is the whole input. Okay, what I did. A slice at 1 gives us an optional, and check if this is equal to, I think. So what's wrong with this? Okay, let's try this out. Zig build test. Oh, yes. So you remember that I said that executable test executable is completely separate. We didn't add our package to our test executable, so we need to add this, and this is why I said we better to use it as a separate, as a value in here, define the package and then add this to any executable we want. So run this again. Okay, it says okay, so the compile needs a needs an allocator. Actually, let me just talk about a bit about testing in Zig. So testing in Zig happens with test, keyword, name of the test, and a block of code. And Zig will transform this into testing, a test, probably a function. And you can put this anywhere in your code base, and you can run tests against them. And like other stuff, there is, as you saw in the build.zig, there is a executable especially for tests, and we can use them, of course. And if you run zig build step tests, it will run the test for you. Normal stuff like other programming languages, nothing really. I don't think anything weird is happening here. There is a allocator specifically for testing, which is basically, I think, just the general purpose allocator. Okay, what I did, let me see. The allocator instance is just general purpose allocator. Okay, back. Let's try this again. There's another bug which is expected. Okay, cast discards constant qualifier. No, I think this pattern should be for. Operator not allowed for this. Yes, okay, this is completely okay. This std_mam equal. We need to use this instead of this. Expected, okay, right, because we need to pass the type of the slice we are going to compare. It's a slice of U8. Okay, so our test passed now, which is nice. You see, our test passed. Okay, so it means that we actually got the captcha correctly. This is really cool. But there is a problem, and that is our memory is leaking. This is one of the good things about general purpose allocator in Zig. It detects memory leaks, especially in the testing scenarios. So we actually know that this code is leaking memory. Since we actually wrote this code in here, it's not actually important for me that it is leaking memory. Well, let's see if we can close these. So actually, let's go into our here. Let's take a look at the regex. That's it, I think. So regex is this struct we are using. Compile creates a regex, right? Okay, and dinit does the dinit. So we need to do a defer. Should we do defer or so? Defer pattern dot dinit. Dinit. Okay. Also, captures return a capture. And captures also have deinit in them. Okay, so I do defer captures.deinit. So it says captures does not support field access, and it's right because it's an optional. Expected type this, found. Yes, we need this to be also a variable. Okay, one test leaked memory. We still have a leaked memory somewhere. I don't know where. Oh, I don't know where is leaking memory. Pattern, we are deinitting pattern. We are deinitting the capture. And captures. You know what? Let's just do this. Expecting this. Expected optional type. Found this. We need to first do a try. And then do this. There's still a leaked memory in here. Okay, so actually let's take a look at this. Maybe this will help us into finding the leak. So it's compile question. What is that? Is this slice at doing some allocation? No. I don't know. I don't know what's actually doing this. Maybe we should put this in here. I don't think so. No. That wasn't something that could break this. Let's actually take a look at the source code of the tests again and see how they are doing the testing, fixing the allocator. So check RE input to match the expected bool. So they created this thing. Do some debug, defer p parser. Deinit. Captures. Okay, so Regex captures. Does they compile the init? Yes. For captures also does the deinit of this. So it will test. If you run the test, they will all pass. So why my tests are not passing? So I'm also deiniting the pattern. Regex test. Let's take a look at in here. Is this? There are also vars. Captures.deinit. Are these differs? Yes, differs. I actually don't know. I don't really know what's leaking. Compile. Is there any other test in the... Test something? I don't know. No, there is not. I don't know. Let's see, what's that? Okay. What's that? okay. Let me silent this. Okay. What is leaking memory? Regex. I don't know. STD memory equal memory address this leaked. It's really hot. Compile question. Also, can you match this as well as a test? Oh, you actually failed. Unexpected result because it didn't match this. Isn't question mark for optionals? Regex? Am I wrong? Should we escape these? Unrecognized escape code. Probably not. I don't know what's leaking. Can we do something like std testing.allocator dot the init itself? Make sure. No? Destroy? I don't know. What's all of these messages? How we can find this? How we can find this leak? You know what? Let's see. Test regex manage. Regex capture. Okay, so capture would fail. We know that. But pattern dot match. Try pattern dot match. See. Two tests passed. Two test leak memory. This is nice. This is nice because actually even this one is leaking memory. So the problem is in here. Pattern.dinit is not necessarily freeing everything. Why is that? So it's in regex itself. So there's the allocator in here. We got the compile and everything. Okay, so compile returns a new regex. There's this D in it. Slots compiled. There's this string, which is just a slice. Okay, so it seems that it is doing everything correctly, deleting everything that is there. What if we do this in here? Still doing the leaking, and I really don't know why. And you know, the thing that is really weird is that its own tests are passing. And this is basically the same thing, right? How this is passing, I really don't know. Click build test. In the build, we are pointing to this file, right? In the test step, add test source all test. Yes, so this is actually how we should probably do testings. So a test all should just import all test files. Test regex test, and this is how it's okay. Okay, it's really weird why we don't get this right. std testing allocator, std testing allocator. We then pass a string. We're also passing a string in here. Prefer pattern dot b or try regex dot compile. Everything looks the same to me. Try testing. Let's say debug, std debug, result. Maybe this function has problems. No. Okay, it's really weird. I don't know what to do actually. Okay, we took a lot of time. We put a lot of time in here. So let's just comment this for now. Let's just go into routes and try to write the regex part. So the regex engine we have, it's in regex dot regex. Okay, so in here we basically just need to match this. So I'm just gonna use that. Oh, I hope that this doesn't mess up our frame size again. I really hope that doesn't do that. stdmem equal this. Okay, so what I do is say I create my pattern in here, maybe even as a constant. So constant, my pattern is regex.compile, passing the allocator. So I need, oh, can't we do this in compile time? I don't know if we can actually use an allocator. Do we have any kind of allocator in, for example, server? Do we have that? No, it's a generic type. Okay. I think we need to have the same thing for this, because we also need a function in it to take an allocator, stdmem allocator, and return pattern itself. Allocator is std.mem.allocator. Allocator is allocator. Okay, so in the main, the router needs a init passing the allocator and the handler. So zig build run gives us this. Okay. It says this is a bounded function. Oh, come on. Why? That's right, because handler is actually a bounded function. Routes. Unless we don't do this in here. And in the handler, in here, we take a comp time allocator, std.mem allocator. Let's make this the first argument. Oh, come on. It says unused function parameter, which is right. So we have the allocator in here. So for each route handler, I'm gonna do regex.compile var pattern allocator, and the pattern would be the route handler. Let's imagine user is just writing valid regexes. And then what we need to do is pattern.match match against the request.uri. We try this, gives us a boolean. If it's true, we return route handler. We don't even do the captures right now. Yes, so let me just answer this call. Sorry. So we match this pattern and we try to make this work. So in here, let's just say that this is a valid regex. Let's hope that this just runs. We won't, because we didn't pass the allocator. I'm sure this is not gonna work because yes, this is a runtime value. Allocator is just runtime value. Allocation is a runtime thing. You cannot do allocation without thing. Oh, come on. This is why I didn't think about it before. Compile time regex. There was this other library, but it had I remember playing with this, but this also had problems with it had problem with compiling. Maybe we should change to this library. Oh, okay. We just spent half of our video working on the dead end. It's really nice. Really nice. Okay, this is really a problem. I don't know what what we should do. We could not use this. This is sure. What other things we can do for path parameters? We can, for now, we can just say we don't do them until we have a good regex implementation for Zig, so we can do it. That's one thing. Other one is to, so we have this project, actually my friend is working on it, as a Go project for routing, and he said that he actually implemented the radix trees, and it also supports path parameters, right? Route parameters. Okay, can I find, okay, for example, this one, right? And it's also using radix trees, not regexes. What is a node? Each node holds a radix tree node including content, node children, and related route. So there's a content, there's this route, and there's this children, which is a slice of nodes. Technically, there should be only, no, not really. A node needs a route and a token. Oh, this is actually really cool. If you just translate this, so you see this function, if you just implement this in Zig, this code, just line by line, we can make sure that these are compile time, because we know everything about them in the compile time, right? And then we can just use this find by request and just return the parameters. This is really nice. We need to implement this. Just let me take a look at what he's doing for register when we are registering the routes. How is he calling the how is he calling the radix tree? I really don't know what he's doing in here. Repository. What is repository? Okay, there's a tree in here. Okay, so tree.add route. Tree. There's this tree instance which we initialize in here. Yes, and then we just add to it. This is really nice. Yes, let's implement this in Zig. So the only thing that I am a bit worried about is this children thing, also this patterns thing. So we cannot use things that are things in Zig that needs allocation, because we are bound to being able to create our routes, our route handler in the compile time, because of the need to figure the frame size. I'm gonna hold on the path parameters part for now, and I hope that someone comes up with a good regex library. So I'm just gonna reset everything. Yes, let's just ignore everything and remove everything. Let's just work on another thing. Let's just work on middlewares. Middlewares hopefully is simpler than path parameters. So what we need for middleware. So what's a middleware? Middleware is a function that takes a handler and returns a new handler. In other languages, this is what it does. So public function let's say authorize middleware. Let's just start with the example. Authorize middleware. So middlewares are so they basically wrap our handler logic, whatever it is, wrap it with some other logics around it. It can be validation, it can be authorization, it can be logging something, and this wrapping can do so. Let me show. Let me explain this in this code. So imagine we are going to say a comp time handler is going to be passed to us, where I did put the handler HTTP server handler. Okay, so handler is import server HTTP server.handler. Take a look. Make sure server is this server.server. Handler is here. Okay, so a handler is just is function, takes a request and response and returns error or void. This is basically the same thing. We should do this. It should return a type that has a handler thing inside. Okay, so what is this? Returns a struct which has a handler function that takes in a request, constant request. Let's just not do this anymore. HTTP HTTP dot request response request is request, response is response, returns an any error or void. Okay, so for example, we want to let's say log request and response middleware. Start with something simple. So imagine we want to log some a handler requests, to run the handler, take the response and log it. Actually, our responses are not necessarily loggable, but let's say that user put the response body inside here. We actually have a writer in here. Well, let's say that's the case. So we do a std debug print, and let's say our requests are able to do print themselves. So like this, or actually we have this debug print, right? It's in request. Debug print request. It's a public function. Takes the self debug print request. Debug print request. Okay. Then we run the handler. Pass the request and response into it. And finally, for example, print response. Let's imagine we are doing it in here. Response. And let's do std debug print in middleware before handler. let's actually try this out. Let's see if this works or not. So in the main, what I'm going to do is index handler, huh? I'm gonna wrap this inside this middleware thing I just created. So middlewares are import middlewares.zip. What was its name? Oh, middlewares.this handler. Let's see if this works. Okay, unable to find http.zip because we didn't specify the format. Consider using try. Why? Oh, okay, it's in here. Try this. Actually, after almost half an hour of failure, it's actually nice that we have at least a compilation. Okay, it says not found. Why? Okay. Oh, okay. No, let's see. Why our handler? Why we are return? Oh, okay, because the route is like this. Okay, that's okay. And addressing use like always. I'm gonna try until we are successful. Okay. Okay, we got this, and you see that it print this twice. One for middleware. Okay, so in middleware before handler. So yes, one time we are printing this inside our request our how why I cannot talk today, inside our request creation, and this is happening inside the middleware. So our middleware system is basically working, and you see middlewares are actually a simple concept because we don't need anything. We can do some weird stuff, but they're actually really simple. So what I need to do, if just Zig had concept of anonymous functions, we could do so much better, but for now I think this is what we need to do. But let's try and see if we can make a function to compose middlewares and the handler together. Let's try this. So let's say I have this constant called middleware, and this is a struct that has a handler that has a before, which is also a handler, right? And has an after, which is also a handler. There's this function handler. std something. Okay, let's remove this, remove this, remove this. So we got before request response, and we got after request response. And these are all tries. So for each handler, we have this. Let's see if we can create this. So this would return a middleware. So return a middleware. So the before I'm thinking about a nice API for the user, so he can, like a pipeline, so he can pass all the middlewares he wants and the handler, and it will wrap all of those. Maybe it's better to so for this handler, maybe it's better to have so what's wrong with this API is that we pass the handler. Can't we do this? Use of undefined value here causes undefined behavior. Let's close this. What was the problem again? Use of undefined value return route handler.handle. Routes. Yes, I'm using this. So in middleware, I'm returning the handler, which is a function. In main, middlewares.log request index handler is our handler. Okay, this seems right. Okay, this will work. This is one way. So give us the handler. Why this does not work? It's a weird thing, actually. I don't get it. Really. Let's see. Yes, it is undefined. Why it's routes? In routes.handler. Let's go into middlewares. Yes. For now, this is how we should create our middlewares. Basically, get a handler and return a handler. We can have. Let's make this at least a bit better. Okay, log request middleware. Public function, for example. For example, accept only middleware. This is actually another maybe useful. For example, we want to just accept JSON. So comp time accept only, and this is a string, and also a comp time handler, which is a handler. So this returns a struct. You know what? I'm thinking maybe we should formalize this. Yes, maybe we should formalize this. We should make this a handler function and then have a constant handler, which is a struct, and it has a public it's a public, it's a function, it's not anything, it's just handler function. It's of type handler function, and it's a public function handler, takes in same things, return, request, response, request, response. Oh, handler function. Now this has a lot of problems. Maybe we can do public function handler. Returns a type. Runtime handler function. This handler function returns a struct. Handler function request response. So in the middleware, it's actually simpler for now. Is it? Yes, it's simpler. I tell you why. Because we can ignore these and this and this. Make this a normal, for example, log request middleware, and then say public constant yes log request middleware. not a constant, but public function log request middleware takes the handler. Handler. This is also handler function, handler function. Handler function defines a handler. Can we compose these together? Not really. Doesn't help us. It's really hard to progress with this project. Everywhere I go is somehow a dead end. This is good actually. I'm gonna keep this because it's a formal way of creating handler. This is nice. And handler. Yes, this is what I want. Can this work even right now? In the main. Okay. Let's just ignore these. In the main, handler function index. Let's see if this works. No, because server.zig 527. This is the problem. It says expected type found this. Yes. Type normal. So basically I just did a new rename. Nothing should fail. Yes, cool. So, but I actually want this to be handler itself. Incremental changing. So handler dot isn't this a public? Handler. In the main, no, in the route handler, for each route handler, we should wrap we should HTTP server handler this is actually a really good thing to do. So because I like this rename, but everything else was just failure. Okay, So basically we did a rename. Let's actually bring back our middlewares at least. So there's a log request middleware. Let's just take this. So log request. It's the handler. So there's this public constant log request with a struct. And this handler is public, of course. Let's not do this. Let's do this. Okay, so log request returns a new hand. Okay, actually this is not okay. Just when I wanted to say, okay, this is not that bad. It's returning a type. Does not need this, and this is a comp time handler function. Okay, so this is basically what is on. For another request, for example, we need the same thing. We always need these handlers to be count times. So accept only so we say if request dot URI, not URI, headers dot get. This is actually accept content type only. There's it's better. And type content type. Get returns a not this, but content type. So if ct and content type are the same, call the handler. Otherwise, response.write print response.respond, I think it was, yes. So we say http.response.status.bad request null content type is wrong. There is a I think 415 is for this, but I think this is good. Okay, I think yes. So I think we added middlewares, not the best way and not the friendliest way, but it's gonna work. So for example, if we want to do this, so let's do constant log request to middlewares.log request. Same goes for accept. I don't want that middleware actually. I don't like it. Actually, let's go into request and do not call this anymore in the creation. Where I'm doing that. debug print request server. Don't do this anymore. In the main, do log request this handler, that handler. That is it. Run this again. Run. We get this. This is me. I'm saying this is not the best one we have, but maybe we can do some things with type info stuff. Type of. There's this type info as well. Maybe we can use those. But for example, if we want to add another middleware, we can just do this. Another. We need to do this, which is not the most friendly way of doing this. But if Zeek added support for anonymous functions, lambdas, basically some way to pass functions around. We can pass functions around right now. A way to construct a function inside a function. We can make a better API. But for now, I think middleware thing is okay. And there were some questions on YouTube on what is actually a middleware. So a middleware, as I said, basically is just something that takes a handler, takes your code, does some stuff before or after it, basically wrap it inside another function. So it does some stuff before your handler or after your handler. And it can, in any step in your middlewares. So imagine you have middleware 1, middleware 2, middleware 3. Then you get your handler. And then after your handler, middleware 3, middleware 2, middleware 1. This is basically how it's done. Okay? And in any of this in any step, middlewares can break the execution and just return a result. For example, with like this we have in here, it can basically stop the execution. So I'm gonna just push a commit. Yes, I'm gonna push a commit says adds middleware. And close this. So now our middlewares are there. One thing, maybe we can add this to route handler. We spent so much time on the regex and stuff. I get a bit tired. Next video we are going to, so actually let's open up a new issue. Better middleware support in route handler. So I want to at least pass it as middlewares as a slice in here. So I have a middlewares, which is middleware. For example, like this. Let's actually do it right now. Let me just answer this. Let me just answer this message and come back. Sorry, let's continue. So let's actually do this right now. So let's say I have this middleware that is very much looks like our handler there. So so these, what if I have this middleware factory like Java, right? So middleware factory. So we have a comp time before, which is a handler function, comp time handler, which is the handler function, and comp time after, which is a handler function. Returns a type, which is a struct. Yes. Let me answer this again, sorry. Okay, so we got this. So what we can do is simple. Try before. Can we do these as optionals? For example, this and this. Okay, public function handler, request, response, and here void try handler, request, response. After. So the log request just returns function log request request.debug print. And this now becomes return middleware factory. Before is log request, handler is handler, after is no. This is actually something I like. Will this work? Hopefully. No. Unable to missing field middleware. So in the routes, ignore this for now. Unable to unwrap null. Why it's that? Let's go into middlewares in here. So let's say if before capture it and say before handler request and response. Same for this. After and after. Yes, we need to try. and try. Okay. Yes. Okay, this is cool. I like this. I like this. Let's add this. Okay, so this is pretty much simpler now. Also, I can make this simpler. So I can basically put this inside here and say content type only. Ignore this. And this works for a log request, but does not work for this. So content type only, we should pass it some way inside. It's really a weakness that we cannot do lambdas in here. It's really a weakness. Let's not do this for now. I don't know what to do with the routes. So if the route has a middlewares inside, which is middleware, the server, what we defined as handler? We didn't. In middlewares, we have this middleware factory. We also public function middleware. Or we can define the type of the middleware as a function that takes a handler fun and returns another handler fun, right? This is for normal middlewares. And this let me say no. Okay, I'm really struggling around with these. Middleware, it's a handler function, gets the handler function, returns the handler function. Okay. Now we can do in main, let's just do this. You know, okay. So let's not do this. Let's say this, right? So what I want is also middlewares. Constant of middlewares, or actually just do what you need to do. So I will add a log request, for example, something like this. And I should pass this into here. So what is log request? Takes the handler fun, returns a type. Let's say this is middleware. And content type only returns a middleware. returns a struct, two nested structs. Public function takes in the handler, returns the type, where's the content type? It's in here. Okay, cool. Let me. Okay, sorry. So now the content type returns a middleware. Middleware is this. Okay. So if we go into the routes, middleware is middleware.middlewares. So if we match, I should do another inline for middlewares for route handler dot middlewares and m var handler, which is the user handler, and then do m as in the handler, it will create type that has a handler, and it will become a new handler. Where is the other? Oh, okay. Final. Let's call this final handler. Final handler. Final handler. Finally, we want the final. Okay, array. Okay. And main, we need here an ampersand. Expected type. In where? Sorry, main.zig line 25. Log request. So middleware factory. Why it's not working? Log request. Okay, isn't each middleware? Okay, so log request is technically a middleware himself. Isn't it? Isn't it a middleware? Okay, sorry. Okay, it's a long video. Okay, I think I'm gonna call it because it's really being hard doing stuff without lambdas. It's really hard. I mean, log request in here, it's technically a middleware because it takes the handler function. Oh, maybe I need to make this a comp time. That's. It says I expect a function that takes in a handler, returns a type, found a function that takes the returns any time. Basically, you cannot infer this. So, sorry again. Let's not use this middleware factory. Let's return a struct. This is struct. Let's just copy this, paste it right in, and it has request.debug print request. What about now? Okay. Okay, I'm gonna call it. And so this does not build. So I will check out to another branch. Our main branch is buildable. And yes, call it. So we have this better middlewares. Actually, we can probably mention the. How was this? Pull requests. Okay, we can mention a pull request. New pull request. Okay. How? Oh, we didn't commit. So work in progress, make route handler accept middlewares. Yes, compare and pull request, create pull request. This is pull request number 6, really? And we can mention this in here, like professionals. Yes, so we should delay this until a usable comp time regex library is found, or we implement radix trees grabbing. Actually, we can add another issue for radix tree. Implement radix tree routing instead of this issue. This issue thing is a good thing because we know where to go next. I'm gonna work on this on the next video. We technically have middlewares, but I don't like them, so we will work on this and then radix tree. So hopefully we can get path parameters. that is it. If you like this content, subscribe and like these videos, and also um, consider that that Zig is really new, so these features missing, these libraries not being there, it's just because it's really new language, really a new technology and a new language. Thank you for watching, and goodbye.